Hello everyone. So now we are heading toward the last chapter of operating system. In this chapter, we will be focusing on the file system implementation. So to have a quick recap, what we have done till now, we discussed in the previous chapter about memory management and how it is how the content is being delivered to CPU whenever it is requesting. So till now we were discussing about memory management in RAM only, so which is called our physical memory or primary memory. So there we use various techniques to efficiently fit the different processes and try to increase the level of multiprogramming by the concept of paging. So most important part was paging and to just bring the data which was needed and by the process, and only those pages were required, and only those pages were actually loaded onto the main memory. Now main memory was backed up by a backstore, which is your secondary storage. It could be your hard disk, it could be your flash memory. So it depends upon the type. Nowadays all laptops those we are using comes with the flash NVM flash memory. So they're very we call them SSDs. They are very fast and they have the different logic. So they do need a different kind of algorithms to work on. The HDD, which is hard disk, so it requires more seek time to actually move to that particular location and bring up the data from there and then put it back into RAM. So there are concepts of how to manage different types of uh, you know secondary storages, and so that it can efficiently deliver the content when is asked by the CPU, and also efficiently store the data so that we can find it quickly. And also it gives us the power how to efficiently look into different file systems. So you are aware about some of the file systems. So you are using Windows. So nowadays we are using NTFS system. Then we have on Linux we use ext4 system. So each and every operating system would have their own file system. So file system is concerned about storing, managing, retrieving, presenting the information and about the files those are saved onto the secondary storage. And also it basically gives us an interface to interact and pull the information from there. So we are going to discuss all those concepts in this lecture. So this is called file system implementation, so which we are going to discuss here. Before we proceed further, so there is a file system structure. Again, there are mm, as an a view, we consider that if we have stored a file, so we click on a file name. So we say that's a logical storage unit. So our file would be stored on only on one particular place. So this is what is the presentation. So that's the logical view of the data. So logically we think that it is a storage logical storage unit. So our file is considered as a logical storage unit, and is a collection of related information together. So if we are storing some file, we consider there is some information in it, and we consider that this is a logical storage unit which has been put onto the secondary uh, hard disk or your SSD backstore or secondary storage. So file system resides on the secondary storage or disk. So this is what is managing. It resides onto the secondary storage. It provides user interface to storage, mapping logical to physical, provides efficient and convenient access to the disk by allowing data to be stored, retrieved efficiently. So all memory management for the secondary storage is done by this file management system. And When we talk about the hard disks, so disk provides in place write, rewrite, and random access. This is the feature which are required. So there are two types of things. One, we want to fetch the data sequentially. Other, maybe we want to fetch the data randomly. So both functionalities should be available when we talk about any file system. So it should be able to provide us random access to data as well as the sequential access to the data. So input output transform is performed in blocks of sectors. So the sectors on the hard disk, we have sectors. I'm talking about HDD. So there are sectors and each sector is divided into blocks. So remember, we talk about frame, we talk about page, and we talked about block. So these things are basically dependent upon hardware. So what page size is there. So we usually try that the block size should also be of same size. So these are normally 512 bytes long. So this is one block which is transferred as is whenever a request is made. So for each and every file, just as an process control um, block, we have file control block. So here the storage structure consists of information about the file. This is used to store the information or the metadata about the file. So what is the file, permission, names, who accessed it. So all that information is stored into file control block. We would abbreviate this as FCB. And then we have device driver. So we talked about this in our very first lectures. So what are device drivers? They control the physical device. So there is one software that is needed to control the physical device. And the file system organized into the layers. So let's talk about those layers here. So at the top layer we have application programs. Those would be using our file system. Then we have a logical file system which give us a view how the information is stored. So we usually stored the file by name. So to us, the logical file system would give a view that all the information, all the files are stored as a name. Then we have file organization module, basic file system, IO control, and here are devices. So let's talk about these one by one. So I go from uh, below to up. So IO control is the one which is interacting and giving commands to the devices. So here you can see the IO control level consists of device drivers, interrupt handlers to transfer information between main memory and the disk system. So given a command like read drive 1 slender 72 track to sector 10. So this is we wanted to read, and then it'll into the memory location this. It outputs a low level hardware specified commands to the hardware controller. So this IO controller will send a converted uh, command to the devices to read the data from the secondary storage. And this device driver usually writes specific bit patterns to special location in the IO controller's memory to tell the controller which device location to act on and what action to be taken place. So there are codes, and the patterns of bits are used to share the information to initiate the action and to retrieve the information. Then we have one level higher is a basic file system. Given commands like retrieve block 120 123 translate to the device driver. This is what is done. It also manages the memory buffer, caches, allocation, freeing, and replacement. So buffer holds the data in transit. So it manages the buffers, so which holds the data which is in transit, and also caches to hold the data which is being used frequently. So this is the responsibility of basic file system. It gives the commands to the lower level components of the file system, and also performs and manages allocation, freeing space, and replacement. We talked about something in page replacement, so here it's also replacement mechanism. So it includes a buffer that holds the data in transit, and caches to hold the data which is frequently being asked. So that would actually reduce the seek time on the hard disk and make it more efficient to work on. The file system organization modules, it which comes just above the basic file system. So it understands the files, the logical addresses, physical blocks. So it basically does the mapping. So it translates the logical block number into the physical block number, and it also manages the free space and disk allocation. So each and every layer, as we are going to discuss, each and every layer has some responsibility to do, and they are doing their work and giving the input to the lower level layers of the file system. So it manages the free space and the disk allocation. Then we have logical file system, which comes at the top, which interacts with the application programs. So it manages the metadata information, translates the name into a file number. So what we see as an application is a file name, just like we write a name, test123 dot py. So it's just a name which we have given. So it translates that name into a file number. It handles the file location by maintaining the file control block. So the file control block are used, so we discuss here. So file control block is managed by our logical file system. It manages it, and these are called in nodes in Unix. So you would encounter this name, and that file control blocks are in node in Unix. So it also performs the directory management, retrieving on all that process, and retrieving information, presenting information, then storing information. All is done by a logical file system and being transferred to the lower level layers. It also provides the file protection. Layering is useful for reducing the complexity and redundancy, because each and every layer would be doing its independent job. So it reduces the complexity also, because they are modules, and modules would reduce the complexity and also redundancy of the work, but adds overhead and can decrease the performance. This translates the file number into this translates the file name into file number, file handle, location of maintaining the file control blocks using innodes. So this is what are the disadvantages and advantages of layering system. But the most important thing is logical layer is reduces the complexity, and logical layers can be implemented by any coding method according to the operating system designer. So if we have layer structure, so most of the protocols you will see, those come with layered structure. So we discussed about operating system is also coming with the layered structure, so we can add in some mandatory modules or kernel modules are there, then we can add on top of the required module. So that is also kind of different structures we are using. So this modular structure is always good for software developers. So this has advantages. There are many file systems those are existing. uh, I don't know how many of you are aware about UFS. Then we had for Windows FAT system and FAT32. You might be aware about FAT32 and FAT, and then NTFS are all aware that we are using these days. Linux has more than 130 types of file system. It supports basically, so it supports, and now comes with the extended file system. So ext3 and ext4 are basically used. Then we see there are many other file systems. So Google file system, then Oracle ASM, Fuse, ZFS is one. Then talking about Hadoop, so we have HDFS. So this is also a file system. So what is the job of a file system is to manage the data. So how your information is being stored, what can how if I want to access my data, so how this is basically being managed, and how it is being stored, where it is being stored, how to bring the data back, what level of protection is being provided. So all that information is basically captured by the file system. Okay, now moving to the file operations.